Welcome to Spring LIB.
A substance is oxidized if it loses electrons. And if it loses electrons, it loses negative things. So the oxidation number becomes more positive. Now, for that to occur, we also have to have a reduction. So if something is reduced, that is going to gain the electrons that the other substance lost. And if it gains negative things, it becomes more negative. So we need both of these to occur for an oxidation reduction reaction to happen. Remember that the oxidation number is 0 for elements in their natural state, how they normally occur. And then also for some substances, you should know that fluorine is -1, oxygen is -2, or -1 as peroxide. And then other substances normally equal their charge. So let's take a look at some examples. So if we take N2 and H2 and make NH3, nitrogen and hydrogen are in their natural states here. So they have oxidation states of 0. N is normally found diatomic, hydrogen is normally found diatomic. And so what's happened over in NH3? Well, H normally has a +1 charge, so the oxidation state of each hydrogen is +1. There's 3 of them. So the overall oxidation state of 3 hydrogens is +3, but we look at each individual one separately. Nitrogen is normally found as a -3. So if you notice here, nitrogen goes from 0 to -3. So nitrogen is reduced, its number went down. Hydrogen went from 0 to 1, its number went up, it got oxidized. So remember, with this +1, there's really 3 of them here. And if you notice, the -3 and the +3 wind up equaling 0. We have a neutral substance in ammonia. We can use that if we don't know the oxidation state of one of our elements. All right, so let's say we have some iron 3 nitrate and solid aluminum, which becomes iron and aluminum nitrate. Okay, elements in their natural state are 0. So let's take a look and see what happens with the rest of it, because for the rest, they're not elements, they're compounds, right? So we just can't call everything 0. Now, nitrate has its overall charge of -1. If it has a charge of -1 and there's 2 of them, right, the nitrates have a total charge of -2. We have to equal 0, which means the iron has to be +2. 2 minus 2 is 0. Over here, our nitrate is -1 and there's 3 of them. And so we need the aluminum with this -3 to equal 0. So aluminum's got to be +3. 3 minus 3 is 0. So let's look. The aluminum went from 0 to +3. So the aluminum is oxidized. Its number went up. Iron went from +2 to 0. Its number went down. Iron got reduced. Okay, let's take a look at chlorine and sodium iodide becoming iodine and sodium chloride. Elements in their natural state, 0. Iodine, a halogen, is -1. Sodium's +1. Sodium here is still +1, and the chloride's -1. We look at their charge. So the sodium stayed the same. The iodine went from -1 to 0, went up. So iodine is oxidized. And the chlorine went from 0 to -1. Its number went down. So the chlorine is reduced. And the last one is a tiny bit tricky. We have lead 2 sulfide and hydrogen peroxide, which becomes lead 2 sulfate and water. Okay. So sulfur here is normally its charge is -2. So the lead's got to be +2, because remember, we have to have the sum equal 0. Now be careful with this one. This is hydrogen peroxide. As a peroxide, the oxidation state of each oxygen is -1, not what it normally is, -2. So here we have 2 -1s, right? Which means that each of the hydrogens has to be +1. Now over on this side, sulfate is normally -2. But we have to see what's going on with our sulfur in this case. So sulfate is normally equal to a charge of -2. This is not a peroxide, so each of the oxygens is -2. Then there's 4 of them. Now remember, the sum has to equal -2. So what -8 is -2? 6. So that means that the sulfur is +6. Each of the oxygens is -2. And so we added everything up to -2. That must mean the lead is +2. So the 2 with the -2 of the sulfate cancel out to 0. In water, oxygen's -2. It's not a peroxide, which must mean that each of the hydrogens is +1. So what happened in this one? The sulfur went from -2 to +6. That got oxidized. And the oxygen went from -1 to -2. It went down. The oxygen is reduced. So the lead and the hydrogen didn't have a change in oxidation state.